Hi, and welcome to the second of two videos for section 5.5. This is the last of the videos for this class, 181. So in this video, we're going to look at substitution rule for definite integrals. So in the first video, we were just finding integrals, and we were adding that plus c. We didn't have an a, b value on the integral symbol. In these examples, or this example, we are going to have a value, and we have to see what do we have to do to change the problem, because we can't just worry about what's inside the integral. We also have to deal with those interval limits. So we have the following. If g prime is continuous on AB, the closed interval AB, and f is continuous on the range of u is equal to some function g of x, or substitution, then the integral from AB of f of g of x times g prime of x, so this is similar to what we were doing before, but because we have limits, or interval points on our integral, this part now becomes still the same, fu du, but the values on the integral are now the function g evaluated at our A point and the function g evaluated at the B point. So let's look at an example. So this is really the key difference here. So the rest of it's all the same that we did in the first video, but now we have to worry about, we can't just leave the original values on the integral. We have to change them because we've made this substitution. So let's say we want to evaluate the integral from 1 to 2 of dx over 3 minus 5x squared. So it's really like 1 over that piece times dx, but to simplify, we put the dx in the numerator. So I'm going to have to do u substitution, and as I said before, look for the pieces inside the parentheses. Those usually tell you what you have to use for the substitution. So I'm going to say u is 3 minus 5x. So that means du is minus 5 dx. So I only have a dx, so I have to get that by itself. So that means dx is minus 1/5 du. But that's only sort of half of what we have to do. Because we have our a and b now on the integral, I have to change, when I rewrite the original problem, I have to change those limit points. So I'm going to say what? When x is equal to 1, my a value, then g of x, which is our u, is equal to 3 minus 5 times our x value 1, which is 3 minus 5 is negative 2. And when x is equal to 2, the upper limit, u is 3 minus 5 times 2. 3 minus 10 is negative 7. So when I rewrite the original now using u substitution, my values on the integral sign are not 1 and 2, they're negative 2 and negative 7. And actually, with our integral rules, we could flip those two so it's -7 and -2, but then we have to bring a negative sign out in front. But it'll all work out okay. If you leave it in this format, we'll show you how it goes through anyways. So we rewrite this thing as what? -1/5, and then 1 over u squared du. So if I pull that -1/5 out, so -2 to -7, integral of u, 1 over u squared, this is like u to the -2. So I add 1, u minus 1, and then divide the whole thing in front by that. So I get what? I get -1 over u. And then, so that's, well, actually I kind of jumped steps there. So all I did here, pull out the -1/5, so I have 1 over u squared du. And now when I take the integral, I get -1/5 times -1 over u, -7 and -2. And when I plug these values in, so I get -1/5 times, and then -1 over 7 minus a -1 over -2. And when you do all the calculations, you should end up with positive 1/14. So again, be careful with your negative signs here, because you have -1/5 in front, -1 over -7, so this is going to become a positive number, and then minus -1 over -2, so this is a positive, but then it becomes negative again. So again, just be careful with your signs, and once you find common denominators, do your multiplication, you should end up with 1/14. Yeah, I'm not going to go through the steps of the number crunching there. So that's if we're evaluating a definite integral. We have to be careful to change our values on the integral sign. So the last thing to throw at you guys here is integrals of symmetric functions. So if we have things like x squared, and we have a parabola, how can we figure out integrals of that? Or if we have x to the third, that's symmetrical about the origin. So we have, suppose f is continuous on the closed interval, and I'm going to write this in red and you'll see why. -a to positive a. So everything else to this point has been what? A to B, A to B, A to B. Well, if you get a problem and it's giving you either the integral already with -2 to positive 2, -10 to positive 10, -pi to positive pi. If the values, if that interval has the same value, but just one is the opposite of the other, opposite sign, that's your red flag. That, you know what, this is probably a symmetric integral. And can I apply this rule? So we have two possibilities. If f is even, so even means what? F of minus x is the same thing as just f of x, i.e. x squared. That's an even function. Then the integral from -a to positive a of fx dx is the same as 2 times going from 0 to a of f of x dx. So think about it. If I have a picture of a parabola and I'm going from -2 to positive 2, and I'm trying to find the area underneath of this, well, we know that a parabola x squared is an even function, so I don't have to figure out the integral from one point to the other. I really just have to figure out half of it and then double it. So figure out half of it, 0 to 2, and then double that value. And if f is odd, so for example, the function x to the third power, the integral from negative a to a of f of x dx is just 0. So think about it. If I have this function x to the third, and I'm figuring out the net area underneath of these, let's say again I'm going to 2 and negative 2, well, on the left side, this value accounts for a negative value. It's considered like a negative area. This side is positive, but they're the same amount of size, so when I add the red, or when I take the black and I subtract the red, they're the same value, so I end up with 0. And again, it's just potentially going to save you some time. If you're given a function, if it's an odd function, instead of having to calculate the integral, you can just say it's an odd function, it's symmetrical, so therefore my value is 0. So that's it. We made it. A lot of information, a lot of videos. You know, thanks for coming along, following along. I know I've got a lot of emails and comments from you guys that these have helped you, so that certainly has made it worth it to me. You know, feel free to tell others about it. Feel free to comment on the videos if you like. Feel free to go to Rate My Professors. Look me up, either UNLV, I have an old one from CSN. I guess since this is for UNLV's Math 181 class, you can rate it there. Maybe just put, you know, that I wasn't really your instructor, but the videos helped you, or whatever the case might be. You know, certainly it would be a help to me down the road. So again, I hope you've gotten some out of this. I hope it's helped you along the way. I wish you the best of luck on your exams and your finals, and hopefully we'll see you guys again someday.